presentation on interactive visualization for AWS cost optimization and resource uses. I am Samrat Lamichhane.
And I'm Carol Lamashane. And together, with my colleague, we have worked on an approach to simplify AWS cost analysis through interactive data visualization. In today's session, we will cover the importance of the AWS cost visualization, how we extract the data, analyze the data, and visualize techniques we plan to use and expected outcomes for this project. By the end, you will understand how this tool can help AWS users to optimize their spending and their usage. So, we're going to be talking about managing cloud costs and effective problem statement. So, pretty much major challenge that we're going to be working on is how to reduce cost and look at the complex billing structures. Traditional reports usually lack interactivity and insights. But with my colleague, we're going to be trying to develop an interactive visualization tools which enables other users to explore the cost trends and inefficiencies. Our project will aim to create an interactive visualization framework that will help businesses understand their AWS spending patterns, identify high cost areas, and optimize resource allocations efficiently. By visualizing costs, the users can make data driven decisions to reduce waste and improve cost budgeting. So, our task definition is going to be um, and interactive visualization tools that allow cloud architects and finance teams to analyze the cost over time by different services that AWS provides and different regions. We will also identify the underutilized resources so people can be aware of what they are spending and what they're not spending and forecast their future spendings based on historical data. We will also detect underutilized resources to optimize spending. We will also compare multiple cost trends using visualizations to um, compare different types. So for this, we're going to come up with a solution, which is a dashboard for multiple interactive visualizations, which is going to be heat maps, time series graphs, and tree maps to identify the most effective approaches. So the primary data that we are going to be using for insights for our visualization is going to be AWS resources. The primary data source is going to be AWS cost and usage report, also known as CUR, which gives us detailed billing and usage information across AWS services. This is going to be our primary data. It will provide detailed billing and usage information across all AWS services. We will also be using the AWS CloudWatch matrix, which will help us track all services performance and data with correlated with its costs. We're also going to be using AWS Cost Compute Optimizer, and this tool provides recommendations on resource efficiency and highlights the underutilized resources. Data extraction is performed by using AWS APIs, and we're going to use Panda to process and clean the data for visualization purposes. So this is going to be our sample data where we're going to be looking at different services that AWS provides, all the usage types, what it's going to be costing, the different timestamps, and we're going to be looking at the regions where the data is including. So by structuring the data efficiently, we can extract key insights. For example, if the cost is unexpectedly increased, users can pinpoint the exact reason by analyzing the cost usage matrix, which allows businesses to take decisions and take actions such as right sizing instances, or switching to reserved pricing for cost savings.
All right, here we can see the summary of key insights that is needed by the users. So on the first one, as we can see, is the cost trends over time, which basically tracks spending patterns to identify spikes, anomalies, and forecast future costs. On the second one, we can see service uses breakdown, which helps us understand which AWS services contribute the most to overall expenses of your overall AWS account. The third one, as we can see, is resource optimization recommendations. It's basically helps you to identify over-provisioned resources and receive cost-saving suggestions. For example, if there's any EC2 instance that are being over-provisioned, that helps you provide recommendations on how to lower the cost. Also, the fourth one that we can see on the screen is regional cost analysis. It basically analyzes the cost variations across different AWS regions to optimize workload placement. And finally, we have custom filtering and drill downs for the details, which basically enables the users to apply the filters and investigate cost drivers at detailed level. Moving on here. So basically, to bring these insights to life and kind of get that granular detail of what's going on, we will implement multiple visualization techniques. The first one is time series graph, which will basically help us track cost fluctuations over time and identify the trends that we can see. The second one is tree maps, which will show the distribution of costs at the service level, meaning it's going to show you what each service is costing you, which allows the users to see which services contribute the most to the bill that's being generated. The third one is heat map. So basically what this will do is it helps you identify high cost AWS regions, again, allowing business to optimize their cloud architecture. The last one is parallel coordinate plots, which will help correlate multiple factors like cost, CPU utilization, and memory uses to highlight inefficiencies. All right, so now we're going to talk about our tools and technologies. So our visualization framework will leverage industry standard tools and technologies like AWS QuickSight for building interactive dashboards, Python, Matplotlib, Seaborn, and Pandas for data processing, Power BI for business intelligence and dashboard creations, and also Plotly and Dash for creating interactive web-based visualization. By using these tools, we ensure the framework is scalable, user-friendly, and adaptable. So a fully functional interactive visualization tool that helps AWS users understand their cost and resource user more effectively than traditional reports. Basically, they will demonstrate the best practice of visualization by integrating multiple views, real-time interactions, and visual encodings. By the end of this project, we aim to deliver a fully functional interactive dashboard that basically provides the users the ability to track their AWS spending, the visualization of various graphical representations that will make cost analysis more intuitive, and interactive filtering where users can filter different data sources. So to bring this project to completion, the next step includes data validation and cleaning, which basically ensures that there's accuracy in the data by refining the extraction process. And then we're going to the dashboard development, which will be building the interactive visualizations using AWS QuickSight and Python. We'll also be working on integration with AWS APIs, which helps automate data retrieval for real-time updates, and also user testing and feedback. To conclude, AWS cost management is a complex yet critical aspect of cloud operations. With the rising cloud adoption, businesses need better visualization tool to make sense out of their own spending, of how much they are spending. This solution will offer interactive cost analysis and optimization insights, giving AWS users greater control over their cloud service and expenditures. Thank you for your time, and I'm here to answer any questions that you might have. Thank you again.
Well, thank you. Um, it looks like an interesting project. One, kind of, I think you've broken down these three things, analyze cost by service and region. That is fine. I mean, that is well defined. Identified underutilized resource, I think that's also well defined, although you have to come up with what is underutilized. I don't know how that definition, but I think you can come up with it's
Right.
more of a general thing than compare multiple cost trends. That tends to be too general because again,
So I
any
can
trends or some trends. So you need to kind of figure out what trends are you comparing. Maybe you don't even know right now until you
Uh,
dive
s-
deeper.
sir, really quick. So we were more so thinking about when we say underutilized resources, right? If we are looking at S3, like which is a storage unit, we're going to be looking at like how much are we predicting to use versus how much we actually use. So that ways we can scale up and scale down accordingly.
Okay, so but you have the data on the prediction.
Oh, yes, sir.
Okay, and but again, it needs to be a number somewhere because if what if you're using 99%? Uh, what is underutilized? Is it or maybe you're showing the level of utilization, but when I call something underutilized, do I start to worry at 10%? Do I start to worry at 5%? Do I start to worry at 50%? That's
so
what I meant. That was my first. It's not a visualization thing. It's more of a definition thing. So I'm not
Yes, sir.
too worried, but uh, kind of that was my first thought. On the multiple cost trends, that can be anything. So any visualization I can come up with, I say, oh, that shows a trend. So you may need, like I said, maybe you don't even know at this point exactly what this is going to be. But overall, I think you need a little glue to kind of get all of these three together. You say, well, we want multiple interactive visualizations. Um, but why multiple? Why not just one? What task do we need to do, or what problem that I need multiple? So can you figure out something that I cannot solve without looking at all three? I kind of by service and region, underutilized, because right now it seems, and that's fine to kind of get a project started. You kind
Mhm.
of look at all possibilities and then you group them together and you kind of figure out a better problem or what the data is telling you. But that's something to keep in mind. And like I said, the first two I think are pretty well defined. This one requires just that, however you define underutilized, pick a number there. That one is not as defined. Um, the data looks fine. I don't have much to say about it. Um, and you're thinking the user would need all of this, but again, what is the problem that they need? Service usage breakdown and cost trends over time. And how would you recommend resource optimization recommendations? Um,
Hey, can you hear me? Sorry.
yes, I can.
Okay, so basically, let me kind of focus on the resource optimization recommendations, right? Like for example, if I'm running my workloads on EC2, which is a virtual machine in AWS, right? And I'm paying like let's say $500 a month right now to run that workload. AWS has multiple different pricing options like reserved instance or kind of where you can actually pay some upfront, so you get kind of up to 70% discount, right? So based on the storage and based on the uses that that your workload have, we can actually get those data from the cost and uses reports and kind of um, educate the users in terms of like, okay, if we are predicting similar or increased workloads in the next 3 months, then we might be able to move to reserved instance, which is going to save us, I mean, at least like, around 70%. So again, these are kind of, just an example that I'm giving, but that's kind of the point in terms of optimizing recommendations. Like, hey, if you move to from standard storage to glacier storage in S3, then you'll be seeing 50% reduction in price. So that's the trend that we look for in the curve, which is cost and usage reports, and then those are the recommendations we come up with.
And it's a good example that you're bringing, and I want to make a point for it, really that applies across the board. Don't assume that your user has more information than what's in the visualization. So if you're making the recommendation, then the visualization should have that recommendation in there. Don't assume that there will be somebody coming in with extra knowledge about the data and they will take it further. So don't assume that I will take that your user will come look at this and then decide, oh, by the way, I know that Amazon has such and such and such, and so I'm going to move to Microsoft. So there's extra knowledge. If there's a 70% reduction, that should show up in the visualization. So the data that is there, that is the data that we have. Nobody assumes that we're going to use this and we're going to plug in more knowledge and more data and we'll solve other problems with it. So
okay, got it.
So it's a very good point, because a lot of people think of, oh, what this can be used for beyond. No, what it can be used for, what you have with the data that you have right now. Many times I have people kind of look, and we're going to look at agricultural impact and then policymakers can take that, and farmers can do that. But policymakers imply, they have extra knowledge that's not in the visualization. So the problem or the task that we are doing, I want you to do, but it needs to be all in the picture.
Yes, sir.
So,
yes, sir.
So yes, if you know there's and you can even make it up and say there's a 70% discount. You can plug it in to the data, or I can have a drop down and select 70% discount, or I have 3 visualizations on top of each other. We're showing 70%, 80%, and 3% discount. But it needs to be there. Do not assume extra, because that opens up a whole can of worms. It doesn't matter, and I cannot judge it on what could be done if I were to bring in this other information. Okay? And again, it's not you. It's like I need to make it clear for everyone kind of where we're going. So it's not everything that you do needs to be done with what we have on the screen, on the visual, what you already put in the visualization. Don't assume that your users or me, I'm going to come up with extra. I know more about it and I will use it to solve other problems. So hopefully that everything one other, and it's not that important of a thing. I noticed React, and where do you plan to use this? Are you trying to make a web-based tool, which is fine, but
so basically we can do that. We're thinking about it if need be, but the other thing is, like, whenever we kind of process the
you don't have
Excel. I mean, it's there as an option, but we probably won't use it. That just as an option.
That's fine. Like I said, you don't have to. It doesn't. I don't care how that visualization is working, as long as it's working. So it doesn't have to be through a website.
Yes, sir.
Or if you want it through a website, it does have to go through other things.
Okay.
Okay, I think that's all I have for this team. And let's see. I'll stop the recording.